Open ChatGPT. Type any question. Watch the answer appear, one word at a time. ChatGPT does it that way. Claude does it that way. Gemini does it that way. Every chatbot you've ever used does it that way. In February of 2026, a startup called Inception released one that doesn't. It writes the entire paragraph in one shot. And against the chatbot you actually use, it's roughly 10 times faster. Here's what it actually looks like. 2 phones, same prompt. Write a 500-word story about coffee. Hit enter on both. The left phone starts ticking words out one by one. Word 1, word 2, word 3. Now look at the right phone. Mercury 2 is already done. The whole story. All 500 words on screen. The left phone is still ticking. Word 4, word 5, word 6. The right phone has been finished for the entire time the left has been typing. It's not faster because it's bigger. It's not faster because it's smarter. It's faster because it broke a rule that every language model since GPT-1 came out in 2018 has obeyed. Mercury 2 isn't strictly better. There's a price. But to see the price, you have to see the trick. And the trick breaks an assumption that's been baked into every chatbot since the beginning. Here's something weird. Every major language model since 2018 uses the exact same trick. GPT-1, GPT-2, GPT-3, GPT-4, GPT-5, Claude, Gemini, Llama, DeepSeek. Every single one of them generates text the same way. They predict the next word, then the next, then the next. Left to right. One at a time. Why? Most people assume it's because that's how language works. We read left to right. We talk one word at a time. So of course models do the same. That's not the reason. The real reason is that next word prediction is the easiest training objective in machine learning. Take any text on the internet, cover up the next word, ask the model to guess what it was. Repeat 1 trillion times. You get free supervision from every document ever written. That's the trick that scaled the entire field. And somewhere along the way, the easy training trick got quietly confused with the only way text could possibly work. Nobody seriously challenged the assumption at commercial scale. Until 2025. Here's the wall in the way. Image generators figured out a different approach years ago called diffusion. You start with a noisy mess and refine it step by step until you get a sharp picture. Beautiful for photos. For text, you hit a problem. Image diffusion works because you can add a little noise to a pixel. You can have something halfway between blue and green. You cannot add a little noise to the word cat. There's no halfway point between cat and dog. The whole idea falls apart the moment you try. That's the wall. It killed every attempt at text diffusion for years, until somebody noticed there was a different kind of noise, and it had been sitting inside BERT the whole time. Here's the trick. Don't add noise. Hide tokens instead. Replace them with one special symbol, a blank, and train the model to fill the blanks back in. The way Mercury 2 actually writes a sentence is a lot like the way you solve a crossword puzzle. You don't fill in a crossword left to right. You scan the whole grid first. You find the clues you're sure about and write those in. Then you use the letters they give you to crack the harder ones. 3 down, morning drink, 6 letters. The answer is coffee. 5 across, feline pet, 3 letters. The answer is cat. Now look at 4 down. You couldn't get it 5 seconds ago. 2 of its letters are now filled in by the words you just wrote. Suddenly the answer is obvious. Mercury 2 does the exact same thing with words. At step 0, every position in the answer is a blank. The model looks at the whole grid at once and predicts what should go in every position simultaneously. It's confident about some of them, the obvious slots, the common words it can almost always guess right. It commits those answers. The hard ones stay blank. Then it runs again. Now with the easy words committed as context, more positions become confident. It commits those, then runs again. After 10 or 20 passes, every blank is filled. And here's the part that actually breaks the rule. Mercury 2's model doesn't have a forward direction. ChatGPT, when it picks the next word, can only see the words behind it. Its head is locked, facing right. Mercury 2 looks every direction at once. Think about what just happened. ChatGPT had to make 1,000 trips through the network to write 1,000 words, 1 word per trip. Mercury 2 made about 15 trips, and every trip filled in 60 words at once. 60 times fewer trips, and every trip runs in parallel, which is exactly what GPU chips are built for. That's how Mercury 2 hits 1,009 tokens per second. ChatGPT and the others sit around 100. Same network, same hardware, completely different way of using it. Roughly 10 times faster at about 1/4 of the price per million tokens. Now here's where this stops being a hype story. Mercury 2 is not strictly better. It pays for the speed in 3 ways. Picture an author sitting down to write. The publisher walks in, drops a stack of paper, and points to the exact page count printed on the cover. They have to fill it. That's Mercury 2. Because every output position starts as a blank, the model has to know how big the grid is before it can fill it. ChatGPT stops whenever it feels done. Mercury 2 has to commit up front. Now picture a detective in a film noir office building a case. Every clue depends on the one before it. By the time they reach the conclusion, every red string on the corkboard runs backward through the whole investigation. That's how the old models reason. Each token sees every step of thinking before it. Mercury 2 doesn't get that chain. A co-founder of Inception has said as much himself. Mercury 2 isn't built to compete with the very largest models on the hardest reasoning. It's built to be fast. The trade-off is real, and it's the trade-off Inception chose. And then there's the part you'll actually feel. You know how it feels to watch ChatGPT type, reading along as the words arrive. By the time it finishes, you've already read most of it. Mercury 2 doesn't work that way. Its whole answer has to denoise in the dark all at once before you see any of it. You sit there staring at a blank box, waiting. Then the whole thing appears. Finished. You're done in less time than ChatGPT, but for those few seconds you had nothing to do. That's the trade. Fixed output length, weaker chained reasoning, no token streaming. So what was left to write secretly buying you? Here's what it was buying you. The slowness of left to right wasn't a flaw. It was the cost of every token getting to think with the full context of every token before it. That cost is what made autoregressive models good at long chains of reasoning. It's exactly the thing Mercury 2 sacrificed to get its speed. So the right question isn't which approach is the future. The right question is what you actually need. Hard reasoning, careful step-by-step problem solving. Stay with the old models. High throughput, real-time agent loops, code completion, translation, structured output. Diffusion is suddenly the better tool. For the first time in the history of large language models, you actually get to choose. And Mercury 2 isn't alone. Inception themselves had a coding model called Mercury Coder a year earlier, in 2025. Google has been quietly testing something called Gemini Diffusion. Researchers released LaDA, an 8 billion parameter, open source masked diffusion model. 4 serious diffusion text models in just over a year. The wall is broken. The assumption is breaking in public. Every architectural choice in deep learning eventually gets questioned. Left to right just took longer than most, because from 2018 until 2025, nobody could find a way around it. Now somebody has. So the next time you watch ChatGPT type a word at a time, just remember, that's a choice now, not a law.